Hi everyone, in this video I'm going to show you a simple design process for a buck converter. So this is the circuit topology. We've got a voltage source that we need to step down to a certain value on the resistor. For a buck converter, we've got a switching network which is composed by a MOSFET and a diode, and then we've got the output low pass filter to filter out the switching frequency harmonics. Let's start with the design process. For this example, we would like to take 12 volts of input voltage and have a 5 volts output voltage with 1 ampere output current. The two parameters that we actually can control are the switching frequency, which in this case we are choosing to be 100 kHz, which is a practical default, for it gives small enough inductance and capacitance without excessive switching loss for a buck converter that has only one switch, and then the duty cycle, which is fixed by the transfer ratio V out over V in, which in this case is 0.42. So the MOSFET is on 42% of every switching period. Now we need to properly size the output filter by choosing the inductance value and capacitance value, and in this case with a target ripple of the inductor current of 25% of the output current and a target ripple of the output voltage of about 50 millivolts, we obtain this inductance and this capacitance, which we can pick a standard 100 microhenry inductor and a slightly oversized capacitor of about 10 microfarads. So now we are ready to build the circuit, and we can plug in these values on LTspice to run the simulation. Okay, so this is the circuit with the correct parameters, and now we can run the simulation to see if everything works. So first of all, we want to know if the MOSFET is switching correctly, and we can say that it is, because this is the voltage waveform across the diode basically, and we can say that about 40% of one switching period the voltage is high, so the MOSFET is working correctly. Then we can check the inductor current to see if the condition on the current ripple is obtained, and looking at the steady state operation, we can say that the voltage ripple, the current ripple is about 300 milliamps, which is basically a third of the output current. So the ripple condition is correct. Then lastly, we want to check the output voltage, and we can look at the steady state operation, and let's see if the voltage ripple condition is obtained, and we can say that is around 40 millivolt. The ripple is a little bit less than the one we choose as a parameter because the value of the capacitor that we chose is a little bit higher, so the ripple is lower. Okay, so that's all for today's video, and in the next one I'm going to explain a little bit more these two quantities, which are the inductor current ripple and the output voltage ripple, and how can we obtain the formulas that we used to calculate the proper inductance and capacitance to size the output filter. Let me know in the comment section if you have any doubt, and I'll see you in the next one.